We look up. We see stars, billions upon billions of them. They've been burning for billions of years. The sheer scale of the universe is breathtaking, almost unimaginable. It makes you wonder, could it be that in all that vastness, across all those stars and galaxies, we are truly alone? What if, instead of being early to the party, we've arrived just as the lights are going out? It's a chilling thought, but it's one we have to confront, because the universe, for all its beauty, is also a very, very quiet place. The Fermi Paradox. In 1950, physicist Enrico Fermi posed a simple question that continues to baffle scientists to this day. Where is everyone? He was talking about aliens, of course. Given the age and size of the universe, it seems statistically impossible that we're the only intelligent life out there. So why haven't we made contact? This is the crux of the Fermi Paradox. The universe should be teeming with life, yet we haven't encountered a single shred of concrete evidence suggesting otherwise. No signals, no spaceships, no alien postcards, nothing. It's enough to make you feel very small and very alone. One possible answer to the Fermi Paradox is the Great Filter Theory. This theory is a fascinating yet daunting concept that attempts to explain why we haven't encountered any signs of extraterrestrial civilizations despite the vastness of the universe. The Fermi Paradox, named after physicist Enrico Fermi, questions why, given the high probability of alien life, we haven't seen any evidence of it. The Great Filter Theory provides a potential answer to this perplexing question. This theory suggests that there's a series of hurdles that life must overcome. These hurdles are not just simple challenges but significant barriers that can prevent a civilization from advancing to a stage where it can communicate or travel across the stars. Imagine a cosmic obstacle course, where each hurdle represents a critical point in the development of life and civilization. To reach a certain level of technological advancement, civilizations must navigate through these hurdles successfully. This includes developing the necessary technology to explore space, communicate over vast distances, and sustain life in harsh environments. The journey from simple life forms to advanced civilizations capable of interstellar travel is fraught with challenges. These hurdles could be anything from asteroid impacts which have the potential to wipe out entire species, to other natural disasters that can set back or even end the progress of a civilization. The history of Earth itself is a testament to the destructive power of such events. To self-annihilation through nuclear war. Human history has shown that our technological advancements can be a double-edged sword. The same technology that allows us to explore the cosmos also has the potential to destroy us. The threat of nuclear war is a stark reminder of the delicate balance we must maintain. The Great Filter Theory posits that some of these hurdles are so difficult, so insurmountable, that they act as a filter, preventing most civilizations from reaching a stage where they can explore the galaxy. These filters could be biological, technological, or even sociological in nature, so improbable that most civilizations simply don't make it. They get filtered out. The idea is that the universe might be teeming with life, but most of it never reaches the point where it can make its presence known. Civilizations rise and fall, often without ever leaving their home planets. Now here's the unsettling part. If the Great Filter is real, it raises a profound question about our own future. Are we on the verge of overcoming these hurdles, or are we yet to face the most challenging ones? The uncertainty of our position in this cosmic gauntlet is what makes the Great Filter Theory so intriguing and terrifying. If the Great Filter is real, we don't know where it lies on the timeline of civilization. It could be behind us, meaning we've already overcome the most significant challenges, or it could be ahead of us, waiting to test our resilience and ingenuity. This ambiguity adds a layer of existential dread to the theory. Are we lucky enough to have already passed it? If so, it would mean that humanity has already navigated through the most perilous stages of development, and we are on our way to becoming an advanced, spacefaring civilization. This would be a cause for optimism and hope. Or is it something that awaits us in the future, a challenge so great that it could potentially end our civilization? The thought that the most significant hurdle is still ahead of us is a sobering one. It suggests that we must be vigilant and prepared for whatever challenges lie in wait. A silent killer lying in wait? The Great Filter could be an unknown threat, something we haven't even conceived of yet. It could be a natural disaster, a technological mishap, or a socio-political crisis. The uncertainty of what the Great Filter might be adds to the mystery and the urgency of understanding our place in the universe. Section 4. A Universe of Whispers, the Drake Equation. In 1961, astronomer Frank Drake attempted to quantify the likelihood of finding intelligent life by creating the Drake Equation. This equation takes into account factors like the rate of star formation, the fraction of stars with planets, and the number of those planets that could support life. While the Drake Equation doesn't give us a definitive answer, it highlights the sheer number of variables at play. Even if the probability of intelligent life arising is incredibly small, the vastness of the universe should still produce a multitude of civilizations. This brings us back to the Fermi Paradox. Where are they? Are we truly alone in this vast cosmic ocean? Frank Drake's pioneering work in 1961 was a monumental step in the search for extraterrestrial intelligence. The Drake Equation, though simple in its form, is profound in its implications. It is a probabilistic argument used to estimate the number of active, communicative extraterrestrial civilizations in the Milky Way galaxy. The equation itself is composed of several terms, each representing a factor that would play a role in the development of such civilizations. The first term in the equation is the average rate of star formation per year in our galaxy. This sets the stage for the entire calculation, as stars are the birthplaces of planets. Next, we consider the fraction of those stars that have planetary systems. With the advent of modern telescopes and space missions, we now know that planets are quite common around stars. The third term is the number of planets per solar system with an environment suitable for life. This is a crucial factor as not all planets can support life as we know it. The fourth term is the fraction of suitable planets on which life actually appears. This is one of the most uncertain factors, as we have yet to discover life beyond Earth. The fifth term is the fraction of planets with life where intelligent life evolves. This brings us to the sixth term, which is the fraction of civilizations that develop a technology that releases detectable signs of their existence into space. Finally, the last term is the length of time such civilizations can communicate. Each of these factors is fraught with uncertainties, but together they form a framework that helps us understand the potential for intelligent life in the universe. The Drake Equation doesn't provide a definitive number, but it does offer a way to organize our ignorance and guide our search. The vastness of the universe, with its billions of stars and potentially even more planets, suggests that even with small probabilities, the sheer numbers could yield many civilizations. Yet, the Fermi Paradox remains: if there are so many potential civilizations, why haven't we found any evidence of them? This question continues to intrigue scientists and fuels ongoing research and exploration. As we continue to explore the cosmos, the Drake Equation serves as a reminder of the possibilities that lie beyond our planet. It encourages us to keep looking, to keep listening, and to never stop wondering about our place in the universe. Are we truly alone? Or is there someone out there waiting to be discovered? Section 5. Searching for Echoes, the Eerie Silence. For decades we've been scanning the cosmos, listening for the faintest whisper from another world. The search for extraterrestrial intelligence, or SETI, has been a monumental effort involving scientists, engineers, and enthusiasts from around the globe. With each passing year, our technology has grown more sophisticated, allowing us to peer deeper into the universe than ever before. Radio telescopes powerful enough to hear a mobile phone conversation on Mars have been trained on distant stars. These colossal instruments, standing as silent sentinels, capture the faintest signals from the depths of space. They sift through the cosmic noise, searching for patterns that might indicate the presence of intelligent life. We've sent probes equipped with golden records containing greetings and music. The Voyager spacecraft, launched in the 1970s, carries messages from Earth, intended for any extraterrestrial beings that might encounter them. These records are a time capsule of humanity, showcasing our culture, our sounds, and our hopes. And yet, silence. Of course, the universe is a big place. The Milky Way alone contains hundreds of billions of stars, and beyond that, there are countless other galaxies, each with their own stars and planets. The sheer scale of the cosmos is both awe-inspiring and daunting. It's a vast ocean, and we are but a tiny boat, casting our net in the hopes of catching a signal. It's entirely possible that alien civilizations are out there just too far away for our current technology to detect. The distances involved are staggering, and even the speed of light, the fastest thing in the universe, takes years to traverse the space between stars. Our instruments, as advanced as they are, might simply not be sensitive enough to pick up the faint signals from these distant worlds. Or perhaps they're using communication methods we can't even comprehend. Our understanding of physics and technology is constantly evolving, but there may be principles and techniques that are beyond our current grasp. Advanced civilizations might use forms of communication that are as alien to us as radio waves would be to an ancient civilization. But with each passing year of silence, the possibility that we're alone becomes a little more real, a little more terrifying. The silence of the cosmos is a profound mystery, one that challenges our understanding of life and our place in the universe. As we continue to search, we must grapple with the possibility that we might be the only ones listening in an empty void. Yet, the quest for knowledge and the hope of finding a kindred spirit among the stars drives us onward, ever listening, ever hopeful. Section 6. Alone in the Vastness and Existential Crisis. The idea of being the only intelligent life in the universe is a lot to process. It's both exhilarating and utterly terrifying. On the one hand, it means we are incredibly special, the sole inheritors of billions of years of cosmic evolution. But it also means we are utterly alone, no one to guide us, no one to learn from, just us, facing the vastness of existence on our own. It begs the question, what is our purpose? What does it mean to be human, to be alive in a universe seemingly devoid of other intelligent life?